Hello and welcome to SBG Support Center. In this second part, we are going to see how to configure your high-performance INS. Let's begin. To configure your device, we recommend to follow this order. First, IMU setup. The reference point is used for the lever arm configuration, as well as the main INS computations. The bar IMU corresponds to the internal IMU center of measurement. For more convenient installation, it's possible to select a different reference point that can be set to the IMU cover target, the base plate alignment hole, or a location of your own selection. In such case, you will need to enter the lever arm between the bar IMU reference point and your custom reference point. Then in sensor, you will select the motion profile that corresponds to your vehicle. Here are the ones currently available, but we also implement new profiles for other firmware versions. Each one of it corresponds to a specific configuration to the Kalman filter, so you have to choose it wisely. In alignment, you will determine the orientation of the IMU by selecting the axis alignment, and if necessary, you can adjust it with the fine misalignment angles. In lever arm section, you will enter the primary lever arm that usually corresponds to the COR, center of rotation of the vehicle, that is mandatory for automotive profiles, for example, or you will choose a reference point. You can also set up to 3 additional monitoring lever arms if you need to output your data on different locations. Let's move to add-in configuration. In add-in assignment, you can configure various add-ins that are connected to your device. You can set GNSS receiver, internal or external, and up to 2 different receivers can be connected either via serial or Ethernet protocol. In case of an external receiver, remember to select PPS signals to synchronize the clock. Depending on the motion profile, you can select additional add-ins such as DVL, odometer, or air data, and much more. If there is an internal GNSS receiver, you may set the reception mode of RTK corrections. In our case, we will configure an interrupt client. In add-in settings, you will configure your add-in selected before. In GNSS setup, you will configure the GNSS, i.e. the receiver and the antenna model used, and the hidden mode. The lever arms entered in this section are considered by the inertial device as accurate within 1 cm in normal conditions. This accuracy is required to reach nominal product performance. If you have lower accuracy lever arm measurements, you can enter a rough lever arm with an accuracy of 10 to 20 cm, then you will need to perform a lever arm calibration procedure. For more information, a dedicated video covers this calibration procedure. Here, auto-rejection is advised for all measurements. This mode automatically detects if a measurement can be trusted or not. Let's see now GNSS differential corrections configuration. Here, a GGA message can be sent on a regular basis if this is required by your network provider. For the interrupt client, there is a list of mount points available to select the correction source required. Here you can configure the input and output interfaces. Serial port communication can be configured by selecting the baud rate, the communication mode, and the desired parity value. In order to configure an Ethernet communication, you can select DHCP or set static IP parameters. 5 Ethernet ports are available to configure independently in TCP server or client or UDP, broadcasted or sent to a specific address. If you are using SBG Center, it will connect automatically to Ethernet 0 to listen to messages output. In this panel, you can enable or disable and configure the bus bitrate. In Logic Input-Output, you can configure TTL output signals of the inertial unit. Sync-in can be used either to synchronize internal clock or receive an event for message output. Sync-out can be used to synchronize external equipment or generate a virtual odometer. Then, in data output, each output port can be configured to output data from a specific location with respect to 4 available lever arms. Each output port can be configured to start outputting data at specific condition, either when the power is on or when the UTC or the position are valid. Presets are available to ease typical use cases, and you can also select manually messages requested either in SBG ECOM, NMEA, or third-party format with specific data rate. In data logger configuration, there is a for mode for resume state. Start off will disable the data logger at power up, and you can enable or disable it manually. Start on will enable the data logger at power up, and you can enable or disable it manually. In resume state, the data logger on or off state is kept from the previous power cycle, and you can enable or disable it manually. And finally, black box is a permanent login mode that overwrites very old logs when the disk is full. In preset selection, support is ideal for post-processing and troubleshooting, so we recommend to select it. Let's move to network time. Here you can select NTP or PTP protocol mode in order to synchronize the INS with other equipment. If you need a tight synchronization and timestamping, we recommend to enable PTP mode. At this stage, the configuration is completed, and you can go in Installation Overview section, where it displays the setup of your installation in a nice 3D view. You can easily check the lever arms consistency with your application. And finally, in administration, it's possible to import or export the settings or restore the default settings and reboot the device. This is the end of this video. I hope you learned a lot of things with me. If you have any question, you can call our technical support team and we will always answer.